Hello students, how are you? I hope you are doing good. So here we are with the question discussion of AIT 5G mains paper that you have given. So we have selected some problems and we are going to solve that problems. So what I find out that these problems are a little bit complex for you guys. So that is why I have selected these problems. We will see the solution of one by one and make them understand. Okay. So we will see the concept behind it and try to solve in an easy way. Now, so without wasting time, let's get started. So the very first question is this. In this question, given that an elevator is moving with an upward acceleration, a coin is dropped from the rest, from the roof of a height h of the elevator. The time after which the coin will strike the base of the elevator is. So let me just solution. Now, in this question, the one thing that you have noticed that the acceleration of lift is given, which means that lift is moving upward with a certain acceleration. Although the gravitational acceleration is also acting in that lift. But so in this case, two accelerations are present. So definitely it is a case of relative motion. So we have to use the concept of relative motion and try to solve this question. Got it? Now, you have seen that in the question, this is the elevator, let's say, this is the coin here, and we have just dropped it, which means if any person inside the lift observing this coin, it seems to be a free fall for this one, for this observer. So the initial velocity of the coin with respect to the lift or this observer present in the lift will be 0. But what about the acceleration? This will fall with a gravitational acceleration g is acting on it. But you will see the lift is also moving upward with an acceleration a. So these acceleration a and g are opposite to each other. So the net acceleration you will see net acceleration is equals to, or effective acceleration you see is equals to a plus g. Now it is a very simple question. Now we have to calculate the time. So for free fall, if an object is free falling at 0 initial velocity with a height h, then time taken by this object should be 2h upon g, if g is the gravitational acceleration. But in this case, the net effective acceleration is a plus g. So time taken by this object to be fall on the roof of the elevator will be 2 times height of the roof, which is given as small h, divided by the effective acceleration, which is a plus g. So this is the time taken by this point. Okay. If you are going to try to solve this question with the frame of reference of ground, it will be very complex problem to you. Okay. So try to solve it in a frame where the coin is present. Okay, where the motion is happening. So option D is the correct option. Now, next point. Next question is this. This is very important question and very conceptual question. Okay. In this question, a stone is projected from the horizontal plane. It attains a maximum height capital H and strikes a stationary smooth wall and fall on the ground vertically below the maximum height. So assuming the collision to be perfectly elastic, the height of the point on the wall where ball will strike is. So this height is to be asked in this question. What is happening in this question? This ball is moving with certain velocity and it is projected with certain angle with the horizontal. Then what is it doing? It is doing its parabolic motion. But here, a plane wall will come and it will strike on it. But this collision is, this is given to us that assuming the collision to be perfectly elastic. So this is a perfect elastic collision. And after that, it reverts back and fall exactly below the maximum height point. So here we are going to use two concepts. So concept number one. In perfectly elastic collision or self elastic collision, perfectly elastic collision, so let's say this is the plane wall and a ball will strike on this with a certain velocity, and in this case, so it has two component of velocity, let's say ux and uy. So if this is the elastic collision, so what will happen after the collision? The component, the horizontal component, which is perpendicular to the plane of contact. This is the plane of contact where this ball should make the contact for collision. So the component perpendicular to the plane of collision will reverse back its direction without change in magnitude. Because in elastic collision, momentum is conserved and kinetic energy is also conserved. So there will be no loss of kinetic energy. That is why the direction of the velocity will change for ux. This is for after collision. But the velocity parallel to the plane of contact will remain same. So this is the first concept that we are going to use, which means the velocity is not going to change in magnitude but in directions. The concept number two that we are going to use, concept two, is this: whenever a body free fall, with certain height h, so the time period taken by this ball to cover this height is equals to root 2h by g. And from this concept, you can say that t square is equals to 2h upon g. Or you can say that this t square is directly proportional to the height. So this concept we are going to use. Another concept in this problem is concept number three, that if the velocity is constant in magnitude, or you can say that the speed is constant, then the distance covered by it, s is equals to v upon t, or you can say that, sorry, v is equals to s upon t. So the s, or the distance, should be equals to v into t, and you can say that the distance is directly proportional to time taken. Okay, so these three concepts we are going to use in this problem, and let's see the solution of it. Now, in this problem, this is the plane wall, and this is the ball which is projected from here, attain the maximum height, and then this is the maximum height point, and then it reverts back after striking. Now, what if this wall is not present? So it will complete its parabolic motion. Complete. But because of this wall present and the collision between them is elastic, this path is just the path traced by the object after collision, is just the replica of the path which is covered by this object in absence of the collision. So it's just the mirror image of it. Okay? Although you can also understand in this way, if the velocity is changing only in direction, not in the magnitude. So it will cover the same distance it will cover before the collision. If collision will not happen, so same it will cover after the collision happen, but in opposite direction. Okay. So let's say this distance is x. So this distance b must be x because it is same. Got it? And this distance, the maximum height point occur at r by 2. And this will also from this is h max. Okay. So from h max, this is also r by 2. So from here you can say that x plus x is equals to r by 2. So 2x is equals to r by 2. And hence we have x is equals to r by 4. Now, this height is given as small h. Now, this point we have considered point A, this point we have considered point B, and this point we have considered point C. Now, if this is h and that is capital H complete, so the difference between them is capital H minus small h. Okay. Now, we are going to use the concept number 1, which is t square is directly proportional to height covered. Okay. And we are going to apply it for A to B, from A to B. So A to B, the time taken will be T of AB square is directly proportional to capital H minus small h, because this is the height covered by this object from A to B. This. Okay. Equation number 1. Then we are going to apply it for A to C. For A to C, what is the height covered? It is the maximum height capital H. So time taken A to C square is directly proportional to capital H. This is equation number 2. Okay. Now, we know that the horizontal velocity of this motion will always be constant because there is no acceleration in the direction, horizontal direction. So we can say that the concept number 2, we can say that the time period taken by it, let's say capital T, to cover this range, this total range will be R. So total range is R is equals to U into UX into T, let's say capital T. So we can say that R is covered is directly proportional to T. Similarly, we can say that for R by 2, it is directly proportional to T by 2. And for R by 4, it is directly proportional to T by 4. So this is we are going to use. Now, taking the ratio of equation 1 and 2. So it will be T of AB by T of AC whole square is equals to capital H minus small h divided by capital H. Now, T of AB, which means A to B. A to B, it has covered x, and x is equals to R by 4. So you can replace this. So for covering R by 4, the time taken would be T by 4. Because this is the relation in between distance covered in horizontal direction and time taken. And also for A to C, it is R by 2. So it is T by 2. You can replace it. Whole square. It is capital H minus small h divided by capital H. Now this T by 4, T by 2 will become 2 square is equals to capital H minus small h divided by h. If you try to solve this, you will have 4h is equals to h minus, just a second, it will be, let me just correct myself. So TAB by TAC. So TAB is this distance, which is R by 4. Okay. And TAC is the distance, which is R by 2. So time taken will be T by 2. So this 2 will go upside, this 4 will go this side. So it will remain 1 by 2 whole square, which is capital H minus small h upon capital H. So from now you can say that it is 4h minus 4 small h is equals to h. From here you can say that this h is equals to nothing but 3h upon 4. So this is the height covered by this projectile. So it's as simple as this. Okay, we only have to use the concept. Now, moving on to the next question. Yes. So two particles are rotating in the same circle with constant speeds. Speed is constant, which means there is no tangential acceleration, which is 10 meter per second and 5 meter per second in anti-clockwise sense, with their initial radii vector being separated by an angle pi by 2. So find the time at which they will collide. And given that the radius is 4 by pi. Now, this question is directly from the relative motion. And also, some concept of circular motion is also going to use in this question. Now, solution of this question. Now, since initially the radii vector is separated by angle of pi by 2. So you can say that this 5 meter per second is also moving in this direction, this 10 meter also moving in this direction. So 10 meter per second is greater than 5 meter per second. So this particle A will reach the particle B first. So what we are going to see, all the observation with respect to the E. Okay. Now, you can say that VAB, you have to calculate velocity of A with respect to B, VA minus VB, because they are in same direction. So 10 minus 5 is equals to 5 meter per second. Okay. Now this, the separation, initial separation, it has to cover. Okay. So initially, what is the separation between A and B? It is this. Because we are chasing this B with A. That is why we are choosing this distance, not this. Okay? Because we are not changing it with B. We are changing this B with A. So the separation between A to B is, so you can clearly see if you divide this circular path in 4 parts. So these are the 3 parts. This is 1, 2, 3, 4, 4 parts. So 1 plus 1 plus 1, 3 parts we have to cover. So you can say that it is 3 by 4th of the entire distance. And entire distance of the circular path is 2 pi into r, and it is a 3 by 4th of it. Okay. Now 2 pi r is given as 4 by pi into 3 by 4. Pi will cancel out a pi. This 4 will cancel out this 4. It is 6 meter. Now simple. The time taken by this will be, you can say this S of AB divided by V of AB. Now S of AB is 6 meter and V of AB is 5 meter per second. So it will give you 1.2 second. So time taken by this particle or the first collision is 1.2 second. Now, no, it is a very important question also. So two masses, small m and 2m, are placed in a fixed horizontal circular smooth hollow tube. This is a tube. So these particles can never come out. Of radius r, as shown. The mass small m is moving with the speed u and the mass 2m is stationary. So after their first collision, the time elapsed for the next collision, which means they first collide with each other. Then they are moving with certain velocities, although these velocities are different. And then the next collision, the second collision will happen. So we have to tell them what is the time between first collision and second collision. Since you can say the coefficient of restitution is given to this is E is equals to 1 by 2. So in each and every type of collision, if I try to solve this question, so in every collision, momentum is conserved. Momentum is conserved. Okay. So momentum is conserved, which means if you try to calculate that by which velocity this 2m mass particle will move, so you have to apply the conservation of momentum. Okay. That is why we are going to find out the velocity, and then we are going to apply the formula of coefficient of restitution, and then we are going to equate it with the distance covered, and then we finally find out the time. So you can say that if you know the formula of coefficient of restitution, so it is velocity of separation, velocity of separation divided by velocity of approach. Okay. So initially you will see the velocity of approach will be, you can say this is the simpler method to solve this question. So velocity of separation is the velocity of one particle with respect to another particle when they are separating with each other. So this is a kind of relative velocity after collision, and that is why we are interested in that. Because if you try to calculate the velocities differently, then also you are going into the relative motion to find out the time for collision. So why not we are moving initially with the relative velocities? So this velocity of separation is the relative velocity of gap. Okay. And that is why we are interested in that. This velocity of approach is the initial velocities of the particles. So let's say the velocity of separation, you will take it as it is. This is velocity of, or you will represent it by velocity of separation divided by velocity of approach, which is nothing but initially it is moving with u minus 0. So you can say that this Vs upon u is equals to 1 by 2. So Vs, velocity of separation, is nothing but u by 2. Okay. Which means this is the relative velocity between them after collision. Relative velocity after collision. After collision. And this is the first collision. Okay. So you can see here the first collision in this tube. The first collision will happen at this point. And after this collision, this is the first collision, they will move separately. So if I sit on one of the particle, we will see, I will see that one of the particle is moving with higher speed, another particle is moving with a low speed. So if I set an observer with one of the masses, so what will happen? This mass will appear to be rest. Only this another mass is moving with respect to me, and it is moving away from me. And that is the velocity of separation, the relative velocity of separation. Okay. So it has to cover the entire length of this circular tube. Okay. Now you can say that the time taken by this, the s divided by s is the distance divided by velocity of separation. This s is nothing but the entire length of this circular tube, which is 2 pi r. Let's say this is 2 pi, small r is given. Vs is nothing but we have find it out. It is u by 2. So you can say that it is 4 pi small r by u. This is the time taken in between first and second collision. So 4 pi r upon u is the correct option. Now move on to the next question. Yeah. Yet by the diagram, it seems to be a very difficult question, but it is a very tricky question, you will see. Okay. So in this question, we have to use the concept of velocity of pulley, movable pulley, and movable object. Object is obviously moving, but the movable pulley concept we have to use here. So in this scenario, if I write, this is the first pulley, this is second pulley, and there is a third pulley here, which is connected by this pulley at this end, and this end is fixed. Okay, this is the fixed end, which is fixed with this pulley. Because of this, this pulley is fixed at A, this pulley is fixed. So this end will also be fixed. Only this end is movable. So you can say here given to you, this is B, this is A. So for the pulley system shown in figure, each of the cables at A and B are given with a velocity 2 meter per second in the direction of A. So it is also pulled with a velocity 2 meter per second, and it is also pulled by a velocity 2 meter per second. So we have to determine the upward velocity V of the load M. So this is the load connected here, M. We have to find out the velocity of this. Now you can clearly see if the velocity is 2 meter per second, so this end will also move with 2 meter per second. Similarly, this is the same cable joining this point. Okay, but here is the movable pulley, so you cannot directly equate it. Okay, you have to find it out. Look, this is 2 meter per second, so definitely this end will also moving 2 meter per second, but this is fixed end. So we know that this is pulley number 1. So we know the formula, two times of velocity, 2 times of velocity of pulley 1 is equals to the V1 plus V2. In this, V1 is VA and V2 is 0 because this is fixed. Another end is fixed. So you can say that this velocity VP1 is nothing but VA by 2, which is 1 meter per second, because VA is equals to 2 meter per second. Now this is the velocity of this pulley, which is 1 meter per second. Okay. So again, we are going to apply this concept for this pulley. So this pulley, 2 times of velocity of pulley 2 is equals to velocity at this end, which is 2 meter per second, plus velocity of this end, which is 1 meter per second. So you can say that velocity of pulley 2 is equals to 3 by 2, which is 1.5 meter per second. And the same velocity will be transferred to the block. So option A is the correct option. Now, next question. Yeah, this is also a very conceptual question. So two circular sheets of same thickness but a different material are placed as shown in figure. So the ratio of their density is ρ1 and ρ2 such that their combined center of mass lies at their contact point O. So in this types of question, what you will do, you will assume the center of mass at the origin. Okay. So whenever and wherever you will choose the center of mass, put the origin at that point and measure all the distances from that point. So it will be very easy, and some of the variables will be easily removed from that question. Okay. And the question will be so easy for you to do. Now, so we have assumed that the center of mass lies at the point of contact. So this is the origin, which is 0, 0. Okay. This is x-axis, this is y-axis. Now the center of mass definitely lies on the x-axis because these are a uniform distribution of mass about the x-axis. Got it? Now, if you talk about the center of mass of this system, x center of mass is given by m1 x1 plus m2 x2 divided by m1 plus m2. We know that the center of mass lies at the point O, and point O we have assumed at 0, 0. So this x coordinate of the system will become 0. So this will also become 0. So it is m1 x1 plus m2 x2 is equals to 0. Now, for if you assume this mass particle to be m1, this mass particle to be m2, so for this x1, you have to move opposite direction in x direction, in minus x direction. So you will have to take this m1 x1 as minus x1 and equals to, if you take this on RHS, it will become minus of m2x, m2x, m2x2. Okay. Now you can cancel this minus sound. So this will be m1x1 equals to m2x2. Now you will see that this x1 is the this x1 is the center of mass of this individual particle, which is at the center of it, or you can say the distance of centroid from the origin. So from origin, the centroid will lie on the center of it. So the distance will be r by 2 because the radius is r. So this distance will be r. This distance will be r. So you can replace this x2 by r, and this x1 is nothing but 4r. Its centroid also lie on the center of it. So it is at 4r. So m1 into 4r is equals to m2 into r. This r and r will cancel out. Now you will have this, that's m1 by m2 is equals to 1 upon 4. Now you know that this mass is given by, the density is equals to mass per unit volume. So you can replace this mass with density into volume. Now m1 is replaced by rho1 v1 divided by m2 is replaced by rho2 v2 is equals to 1 by 4. Now rho1 and rho2 we have to calculate. So we will take this aside. V1 is the volume of this sheet. Now this sheet is also have some thickness. So the formula for volume of it will be what? Area into thickness. Area into thickness. Similarly, this is for 1 and this area and thickness for 2. Area into thickness for 2 equals to 1 by 4. Now we know that rho1 by rho2, we know that, and it is also given in the question that the thickness of the sheets are same thickness. So we can cancel out the thickness. So only area will remain in here. A1 by A2 is equals to 1 by 4. Rho1 by rho2 equals to 1 by 4 A2 by A1. We will take it in the RHS side. So 1 by 4 into A2. A2 is the area of this sheet. This sheet. The area of this sheet will be pi r square. Simple. Pi r square. But for A1, the radius is 4r. So it will become pi into 4r square. This pi r square and pi square will cancel out. 1 upon 4. This 4 square will become 16 and it will become 64. So this rho1 by rho2 you will have as 1 by 64 or 1 is to 64. So this is the answer. Option D is the correct option. Now, a spherical planet has a mass mp and diameter d. A particle of mass m falling freely near the surface of this planet will experience an acceleration due to gravity equal to. Now we know that each of the heavy mass particle will attract a small mass particle with a force directly directed towards the radial direction. Okay, so that force is F is equals to the force of gravitation is equals to G m1 m2 upon r square. where r is the distance of the center of them. Okay. Now here in this scenario, a particle or planet of mass mp is given, and the diameter of the planet is given, which is dp. So radius will be dp by 2. Now, a mass particle is experiencing a force near the surface of it. So since it is away from the surface, let's say this is h, but we can say that h is very, very less than this r of planet. So we can neglect this h, only rp will be taken into consideration. So we can say that the force is equals to nothing but g, mass of planet, mass of object, divided by the distance, which is radius. But in the option you will see only, on the option you will see, in the option you will see only dp is there in terms of diameter. So we'll put r is rp square. Let's say first it is rp square. The force of gravitation is gmp m divided by rp is nothing but half of the diameter. So it will be dp by 2 whole square. Now gmpm divided by dp square, and this 4 will come upside. Now, according to Newton's second law, this force is equals to mass into acceleration of the planet. Now, force we have as 4gmpm divided by dp square, and it will be mass of the particle by the acceleration experienced by that particle. This m and m will get cancelled out. So acceleration you will have as 4g mp divided by dp whole square. This is option number C, the correct option. The only silly mistake that you can do here, you will put, you forgot to change this rp into dp. Okay. Or what silly mistake you can do in hurry, you can put this rp is equals to 2 times of b. This is the very common silly mistake that students. Okay. Try to avoid this. No. A long cylindrical glass vessel has a small hole of radius r at its bottom. The depth to which the vessel can be lowered vertically in the deep water bath, the surface tension of the water is T, without any water entering inside is. So it's a very interesting question and very conceptual question also. Now, let's say this is the cylindrical vessel we have. I have taken it large for the purpose. So this is the base area of it, let's say. And this is the hole inside it. Now, when we have taken this into a liquid bath, let's say up to height h. So what will happen? The pressure inside the liquid, the liquid will exert the pressure on it, the buoyant force. In respect to that, the liquid will try to enter in this hole. So initially, let's say this hole is like this, but the water is trying to enter in this hole. But up to which point it can hold? So it will be a wobbly surface in there. The water will appear like this, a curved surface. The curved surface will break if the pressure exerted by the liquid exceeds the value of surface tension exerted by the liquid. Now, this is the case of a bubble which has one interface. Only this interface is, other is the liquid. Inside there is a liquid, but outside there is an air. So this is the contact surface will be here. So that is why this bubble or half bubble, you can say, will exert a surface tension along these lines. So this pressure will be equalized by the surface tension provided by this curved surface here. The surface tension will act along the length to it just to oppose this. Okay. And we know that in case of bubble, what is the formula? In case of bubble, or if you will not say, we can directly apply it that the pressure inside it, the force must be balanced. So the force exerted by the pressure, which is P into area of the surface of this surface, is must be equals to the surface tension provided this surface multiplied by the length, and length is 2 pi small r. Okay, this area, we know that at depth h, if the depth is h, what is the pressure? Pressure will be rho g h. So it is rho g into h, and what is the area? Area is pi r square, 3 into 2 pi r. You can cancel this pi and this r, 1 power of this r. So you can say that this h is nothing but 2t upon rho g h. Okay. So this is the method of it. Got it? Now, option C is the correct option. Move on to the next question. The length of a road is increased by 0.1% under a load. Poisson's ratio of the material of the road is 0.1. Then the percentage change in the volume of the road will be. Now, this question is from unit and dimensions. We will try to solve this question. We know that, which is given in the question, the percentage increase in the length is 0.1. Or you can say, which is given in the question. This is given in the question. So you can say that delta L by L is equals to 0.1 by 100. And Poisson's ratio is also given. Now Poisson's ratio is equals to minus of strain in transverse direction. Strain in, or you can say that transverse strain to the longitudinal strain. Longitudinal strain. Now, if this is the cylindrical rod and we have applied a force on that, so definitely the length will increase. Definitely the length will increase. But for the volume constancy, the radius or this vertical length or this vertical dimension will decrease. And that is the ratio of, and that is called the Poisson's ratio. And that is why we have taken negative, because the one of the dimension is decreasing. So here the transverse strain is this, and this is nothing but the radius. So you can say that delta R by R. This is the change in the, or you can say this is the transverse strain. So Poisson's ratio is given you as 0.1. Transverse strain is delta R by R divided by longitudinal strain is change in length by length. So you can say that delta R by R, which is minus, is nothing but delta R by R is equals to 0.1 into delta L by L, negative. Now, we know that we have volume is equals to, for a cylindrical rod, if I want to calculate, this is the length of it, L, and this is the radius, this is the diameter, or you will say half of it is the radius. So you can say the area volume of this road is pi r square into L. So if you want to calculate the percentage change, that is delta V by V. So it is very simple. You have to follow just follow the same rule of logarithmic. So logarithmic is nothing but if you take the log of it, it will in multiply, so it will get plus, and this power will come in front. And this pi, which is a constant quantity, will have no effect in the change. So 2 times of delta R divided by R plus 2 plus delta L by L. Okay. Now delta R by R is nothing but minus 0.1 delta L by L plus delta L by L. So it is nothing but it will become 0.2 but minus, and it is plus delta L by L. So it will become 0.8 minus 0.8 delta L by L. This is delta V by V. If you put the value of delta L by L here, it is 0.1 by 100. And since you have to calculate the percentage change, so you have to multiply both the side with 100. This 100 will cancel out and it will give you 0.8%. This minus integrate, there is a reduction in the volume. The reduction in the volume. Okay. Now, so option B is the correct option. If plus and minus variation are given in the option, you should always choose the negative. Okay. Now, in this question is also from fluid mechanics. If the density of solid object is less than the density of fluid, then so this is one scenario. It is at rest and this is moving with an acceleration of a. Now, it is given that density of solid, let's say density of solid is this, and density of liquid is rho L. So density of solid is less than the density of liquid. So it directly tells us that this solid object will float in this liquid, will try to float or going upward. Okay. So it will exert, the liquid will exert a buoyant force on this particle. The force of buoyancy will act on this, and the force of buoyancy will try to lift this object in the upward direction. So in this case, in the first case, when it is at rest, so the buoyant force FB will act in the upward side. Okay. And there is a tension developed in this. Also, you can take the weight of it, but I'm considering that the objects are same. So masses of the object will also same. So this FB is directly proportional to this tension. Now, you know that this FB is nothing but rho into volume immersed into G. Now, since you can see that the complete volume is immersed in the liquid, so we have taken it is rho V G in the first case. In the case when the system is in rest. But when the system is moving with the upward acceleration A, now this is the tension developed, which is T dash, and there is a force of buoyancy FB dash. Now, volume immersed is same. Density of liquid will also same. Volume immersed is also same, but the effective acceleration will change. Since this is the force of gravitation which is acting downward, and the acceleration provided by us is moving upward, so effective acceleration will be A plus G. So you can see that it is just the here this tension will equating only rho Vg, but this tension T dash is equating rho Vg plus rho Va. So there is an extra term come here. So that is why we can say that T dash is greater than T. Okay. So this option B is the correct option. Now, In this question, if you will see, if the terminal speed of a sphere of gold, which is a density 19.5 kilogram per meter cube, is 0.2 meter per second in a viscous fluid. The density of the liquid is also given 1.5 kilogram per meter cube. Now find the terminal speed of a sphere of silver of same size in the same liquid. So we have two cases. This is the liquid and this is a sphere of gold. Same liquid we have taken, but the sphere is now of silver. We know that the terminal velocity is given by 2 by 9 radius square by coefficient of viscosity into rho minus sigma into g, where rho is the density of body or density of solid, and sigma is the density of liquid. Okay. We know that the terminal velocity in first case is 0.2. We want to find out the terminal velocity in this case. So what we are going to do? We are going to do the ratio of it. Velocity terminal in case of gold is given by 2 by 9 r square, because the same size is given, so radius will also same fluid we are using, so coefficient of viscosity will also same. Only this will vary, rho 1 minus sigma into g, because we are not changing the liquid, so the liquid density will also not change. Okay, so terminal velocity of silver will also be 2 by 9 r square by eta into this I will represent it as gold, and this is at silver, minus sigma into g. Got it? Now, if you take the ratio of it, Vt of gold, Vt of silver is equals to, these old terms will cancel out, and let's say 2 by 9 r square by eta rho of gold minus sigma into g divided by 2 by 9 r square by eta into rho of silver minus sigma into g. These old terms will be cancelled out. Only the terms will remain is rho of gold minus sigma divided by rho of solid minus sigma. And this velocity, terminal velocity of gold is given you as 2 meter per second divided by velocity terminal of silver. If you put the value, densities are given to you. Density of gold is 19.5, and the density of liquid is 0.5 divided by 1.5, and divided by density of silver is given you as 10.5. It is not 0.5, it is 1.5. Density of silver is 10.5 minus 1.5. So when you will calculate this, so Vt will you have as 1 meter per second. Okay. So sorry, 0.1 meter per second. So option C is the correct option. Okay. Move on to the next question. This question you can do by two different methods. Okay. Now, just give me the 10 seconds. Okay. So, in this question, graph is given. So, you can do this question by graph and by integration. So firstly, we will see the method number 1. Method 1. So, in this question, an acceleration time of graph is given. This point is 8. This is also 8. This point is 4. Okay, and this is 0, a into t. So firstly, what we are going to do, we are going to relate this acceleration with time. And then we are going to use the equation dv by dt, which is equals to a. Put the expression of a in that equation and try to integrate that to get the expression of velocity. So now we know that this is the straight line. This coordinate is 0, 8, and these coordinates are 8, 0. So we are trying to write the equation of this line, which is y minus y1. Y we have taken as a minus, this is, let's say, x1, y1, this is x2, y2. So y minus y1 is a minus a, is equals to y2 minus y1, which is 8 minus 0, divided by x2 minus x1, which is 8 minus, this is x1, y1, this is x2, y2. So it is y2 minus y1. So it is 0 minus 8. And in the denominator, it will be 8 minus 0 into x minus x1. So we have replaced the x-axis with time. So it is t minus x1, which is 0. So you can say that xa is equals to nothing but minus t plus 8. Now you can write this a to be dv by dt is equals to minus of t plus 8. dv is equals to minus t plus 8 integration dt. Integration dv. So at t is equals to 0, you can see in the question, the velocity is 3 meter per second at time t is equals to 0. So at 0, it is 3. At time 4 seconds, we have to calculate it. Let's say v. So it is v minus 3 is equals to minus t square by 2. Integration of t dt will be x t square by 2. Limits are 0 to 4 plus 8. Integration of dt will be t, and limits are 4 to 0. So directly I'm writing it as 4 minus 0. Put the limit in that. So you will have 4 square by 2 minus 0 square by 2. So it will be 0. 4 square by 2 will become 8 minus 8 plus this will become 32. So you will have 24. V minus 3 is equals to 24. So V you have as 27 meter per second. Okay. Now this is the method number 1. With method number 2, how you can solve this question, which is much easier way to solve this. This is A, this is T. At this point of time, 4 is given to you. This time is 8 second. This is 0 and this is also 8. Now, we know that the acceleration is change in velocity with change in time. And we also know that the graph, area of this graph, area of AT graph gives us velocity. We know that. So we are going to know the change in velocity from 0 to 4. Okay. So change in velocity we can calculate by the area. This is area 1, this is area 2. So 0 to 4 we have a rectangle and a triangle. So 0 to 4 we are going to calculate the area, which is delta V, which is equals to 1 by 2 times area of the triangle, base which is 4, and height which is also 4. So this is 4 you have seen. So you can say that this is the height of this triangle will also be plus the rectangle, area of this rectangle is 4 into 4. 4 into 4. So this 2, it will become 2 4 ja 8 plus 4 4 ja 16, which is 24. And delta V is nothing but V minus 3. Final velocity minus initial velocity. So V is equals to 27 meter per second. Okay. So you can use both of the methods. Now, this is also a very interesting question. and students generally find a problem in this type of question. A boat, a boat which has a speed of 5 km per hour in still water. You can say that still water and will be considered as the velocity with respect to river of boat. Crosses a river of width 1 km. So 1 km width is given for this. This is width is 1 km width of the river. And we want to cross this river with the shortest possible path in 15 minutes. Okay. So what is the velocity of the river water in kilometer per hour? So we can say that to to cross to cross the river in by shortest path, the actual component observed from ground, the actual component of velocity of boat, which is VB, observed from the ground will be perpendicular to the river velocity. Okay. So if river is flowing in this direction, so there must be the VBR should be in this direction. So this is VBR. So you will have to take the reverse of it, which is minus VR. Okay. You can see that this VR and VB at the 90-degree angle. Got it? So you can say that this time taken will be width upon the VB vector. So VB is the resultant of VBR, which is in still water. Or let's say this is not VBR. Velocity of boat with respect to river should be in the perpendicular direction. So velocity of boat should be in this way. Okay. So we can calculate it by this method. So the perpendicular components are there. So if two components are perpendicular, the resultant will be given as a square plus b square. But what we can say, this VR is in negative direction. VR is in negative direction, so we'll have to take a square minus b square. So we can say that width is 1 km, square root of VBR, which is given to as 5 km per hour, 5 square minus VB that we are interested in. Sorry, VR, because it is the resultant of VR and VBR. Okay, so VR square. Now this time taken is 15 minutes, so we have to convert it into R. So 15 minutes is equals to 1/4 of the R. So you can say that if you take the square of it, it will become 1/16 is equals to 1/25 minus VR square. So you will say that 25 minus VR square is equals to 16. VR square is equals to 25 minus 16, which is 9. So VR square is equals to 9. So VR will become 3 km per hour. And this is the velocity of river. Okay. Now, the gravitational potential difference between a point on surface of a planet and another point 10 meter above is 4 joule per kg. Considering the gravitational field to be uniform, how much work is to be done in moving a mass of 2 kg from the surface to a point 5 meter above the surface? So this is the sphere we have. This is the planet we have. And let's say this is the surface of it. And the potential difference from the surface to a height 10 meter is given as delta V is equals to, and let me write it here, delta V is given as 4 joule per kg. Okay. Now we have to calculate, there is a mass of 2 kg and we have to lift it from 5 meter, from 5 meter to the 10 meter. Okay. So we have to move this from 0 to 5 because we have to move this of mass of 2 kg from surface to a point 5 meter above the surface. And we need to calculate the work done in that. Now, for work done, because we know that work done here is nothing but force into displacement. The force is acting here is the gravitational force of attraction. We can also write it as mass into gravitational field intensity into distance. Now this gravitational field intensity we can calculate with the help of this potential difference. We know that delta V here is nothing but minus of E dot delta R, which is the displacement. Now, we know that, and it is given in the question that you have to consider the gravitational field to be uniform. So, the field that we get here is the uniform for all the point. Now, delta V is given as 4 minus E is given as, no, E is not given. E you have to calculate. And delta R, this delta V is given from surface to 10 meter, which is 10. So E you will have as 4 by 10. Okay. You can say that it is E. And E has the same dimension of gravitational acceleration. So you can say that meter per second square. Okay. Now, we have to find out the work done. Work done is nothing but mass into intensity, gravitational intensity, or you will say the gravitational acceleration into displacement. Displacement, we have to give this particle from 0 to 5. Mass is 2. This is 4 by 10 into 5. 5 to the 10. 2 will cancel out. So work done will be 4 joule. Although it will be appear negative, which means we are working in a conservative field. Okay, that is why I have neglected the minus C. Okay, got it. So this is it from my side. I hope this would be helpful for you guys, and try to solve as many questions as you can. Thank you so much for being attentive. Thank you so much. Got it.